Well, hello everybody. This really is the bonus quiz for 5.8, but I think it's absolutely essential that I pause the course at this moment and give you a map. That is, show you the future and revisit the past, because this is the point in the class where things start to really build up. There's been a lot of math gone underneath the bridge, and what happens is that students tend to get spun. And it's a good time to reflect on where we've been and where we're going. Now, this is the bulletin post for section 5.8, which is where we are today. And I noticed, well, what I wrote here was that think of chapter 5 as a model for chapters 6 through 9. And that's the look forward. Essentially, what's happened here in chapter 5, if you've noticed, is that we've had 8 sections. And 5.1 through 5.7, we haven't seen an equation or a word problem. It's all been about manipulating expressions. And now suddenly in 5.8, we have equations and a small section of word problems. And that's the way it's going to be from now on forward. Let me show you an interesting thing. Our textbook actually has a website. Here is our textbook. And what I thought I'd do is look at the table of contents, in particular the next chapter, which I think tends to be one of the most difficult chapters. Now, look, it begins with expressions, multiplying and dividing. And then it revisits adding and subtracting expressions and more expressions. It's not until we get to 6.4 that we actually see equations again. And then in 6.5 we have word problems. And it's the same with chapter 7. Check it out. Here's expressions. And here again, we're learning how to multiply radical expressions and then how to divide them. And here we're learning how to add radical expressions. And then it's not until deep in the chapter that we get to equations and then again word problems. So that's the way the thing is going to unwind going forward here. Now, I thought it would be interesting to also look back because I want to place you clearly in the present, and it really pays dividends to look back. Now, from the very beginning, I was always talking about expressions or equations, and you just saw why that's important going forward. You need to orientate yourself. This was from 1.3, and notice it's an equation, and the game here was to solve for x, to isolate x and to solve for it. And if you recall, x only has one value here. It's not a variable, it's an unknown. And I'm sure all of you can solve this for x. In chapter 2, things increased in difficulty quite a bit. Now, here's a condensation of all of chapter 2. Suddenly, we had two variables inside one equation. Not just x by itself, but y. And there were an infinite number of solutions. These aren't so much unknowns as they are variables. And all the solutions that work in here, we found were on a line. And in particular, this line has a slope of 1, and this line here has about a slope of 1. And anything, any point that wasn't on that line didn't work in here. And then also in chapter 2, what happened was when we got y isolated, we can substitute it in with function notation. So we would let f of x stand in for y. And the reason why this was a good move at this point in your math education is because it lends itself to the input-output model of the universe. I want to know what f of 1 is, so I replace x with 1 here, and it would deliver us y, in this case 3. And of course, you could view this situation as an ordered pair. And so the input and the output, and that's very important for scientific endeavors. In section 3, what happened was we just suddenly had 2 equations. We had systems. And the game there was one of finding the intersection of these 2 lines. And again, I'm going to actually point forward here towards chapter 4. If you recall, there was the idea of intersection, and that was the points that worked in 2 things simultaneously. And that's the same idea here. This is the one point that works in both of these equations simultaneously. And if I want to take the union of this system, we didn't really do that, but if I wanted to, it would be all the points that work in one line or the other. And so that leads us to chapter 4, where we did have unions and intersections and inequalities. I have an inequality here, and an inequality here, and then we had a system of inequalities. And the game was to draw the lines and look at the pie slices and find the one slice whose points would all work in both of these simultaneously, the intersection of these 2 inequalities. This is the proper pie section. If you were to take x is equal to 0 and y is equal to 4, 4 here and 0 here, 4 here and 0 here, you'd find out that both inequalities are true, and that's true for all the points in this sector. So that's through chapters 1 and 4, and now we're into chapter 5, where we've been dealing with expressions exclusively until suddenly in 5.8 we have equations. Now this is different than anything we've seen before. Yeah, there's only one unknown, like in 1.3, but what's different here is this unknown is to the second power, and that changes things dramatically, and that becomes a heavy part of the second half of the course. Now, what I want you to key on is when you have an unknown that's to a second power, you're going to have two solutions. An unknown to a third power, three solutions. There may be some duplicate solutions, but the idea is the power determines the number of solutions. That's actually called the fundamental theorem of algebra. And you'll see that when you get to Math 151. The game here, though, is to solve this for B. And the technique taught there is to get everything on one side and 0 on the other. So my first move here was to subtract 10b from both sides. So I have everything on one side and 0 on the other. Now I have a trinomial here, and we learned earlier in chapter 5 how to crack these. And so we're looking to form two binomials that multiply to 0. And we're going to use the what's called the principle of zero products. For two numbers to multiply to 0, either this one has to be 0 or this one has to be 0. First, let us crack this trinomial. We're looking for two numbers that multiply to 25 and add to negative 10. Well, clearly 5 and 5 multiply to 25, but they don't add to negative 10. However, negative 5 and negative 5 do multiply to positive 25 and do add to negative 10. Once you find these magic numbers, you have cracked the trinomial, and it is minus 5 and minus 5 that satisfy the two conditions. And this is in a case of what we call duplicate roots. I said there's two solutions, and in this case, it's the same solution. So there's a multiplicity here, a duplication. You can see why there's always going to be two possible solutions. Sometimes there'll be the exact solution. Now, what makes this 0? What value of b makes this 0? And the answer is 5. And what value of b makes this 0? The answer is 5. That's redundant. So we're only going to worry about the one solution here. And that's what we want to put in here. The solution is b is equal to 5. You can put 5 in here and run this, and the left side will reduce to 0 equal the right side, which is 0. So let me go ahead and put that answer in. B is equal to 5. And let's dial up problem 2. And this is a domain problem here. What they're asking us to do is find the domain of this function. And we know that the default condition is we want the domain to be all real numbers, except when we violate some principal law of math, and that would be having 0 in the denominator. So essentially, we set the denominator equal to 0, and we solve this for x. I see x is to the second power, and so I'm thinking two solutions. This isn't a trinomial, so I can't factor it into two binomials. All I can do really is factor out the largest byte from both terms, and in this case it's an x. Well, actually it's a 4x. This has a factor of 4 in it. So I'm going to pull a 4x out from this first term, which means the only thing that gets left behind is the nominal factor of 1. And then I'm going to pull 4 out from the 12, which is going to leave a factor of 3 behind. And I took two x's, I took one of them. And so we have this is equal to 0. Once again, we have two numbers, this number and this number multiplying to 0. And once again, we want to know what values of x make this bubble 0 and this bubble 0. Well, I can see that when x is equal to 0, 4 times 0 will be 0. That's one solution. And here, this is a little bit more complicated. Let's yank it out. We want to know when this is equal to 0. I'm going to add 3x to both sides. And then I'm going to divide both sides by 3. Well, let me just rewrite this right to left. And now we'll divide both sides by 3. And we get x is equal to 1/3. So the two answers are 0 and 1/3. Both of those will make this expression here in the bottom 0. So we have to exclude them. It's all real numbers except for when x is equal to 0 or 1/3. So here's a submit. Thanks for listening. Be talking to you again soon.